Okay, we're going to look at solving quadratic problems. So they've given us some information. We have to build a question. We have a pool that has a width of 5 meters and a length of 8. There's a deck being built around the pool that is uniform, and the area of the deck itself is 68 meters squared. This is tough. I usually read problems 2-3 times to get a good idea of it. So the pool's width is 5 meters and the length is 8. So I'm going to try to draw a picture of this. I always find that very helpful when working with word problems. I'll try to make it as realistic as possible. So my width is 5 and my length is a little bigger. It's 8. So let's say that this is our pool. This is 5 meters and this is 8 meters. Perfect. So here's our pool. And then a deck is being built around it that's uniform. So what they mean by this is the width of the deck is the same everywhere. Okay? So I'm going to show you what that would look like. We'll put the deck in a different color. Maybe red. Go away, please. Okay. So if you notice, what that means is our deck that's going around this is the same width everywhere. Okay, so if you notice, each of these ends up being little squares. We could build little squares to create this deck because it's uniform all the way around. But the actual deck itself is not a square because the width wasn't the same as the length. Okay, and what they've also told us is that this area of just the deck, so I'm going to highlight just the deck's area in purple here. All of this area here is 68 meters. 68 meters squared. Okay, so we need to kind of piece some information together. In other words, I need to find out what the width of the deck is. So I'm going to call that x. And it's x everywhere. Okay, so now let's build an equation for the length of our deck. Well, we know it was originally 8 from here to here. Okay, so now it's 8. And what's the distance here? How far is that?
That's about 1 meter.
Well, it looks like 1 unit, but we don't really know. I haven't drawn this to scale. So what variable have we given it?
X.
X. And what about this distance here?
X.
X. So there are 2 x's. So it's 8 plus 2x. That would be the length of the deck. Where the width of the deck, we know that from here to here is 5. So we know it's 5
plus 2x.
Plus 2x. So this is the width of our deck. Okay? And then the problem with this here is we want to find our area of our deck here. And the total area of this, we kind of want to figure out. Okay? So we actually have to do a little bit more information. I actually got to find the area of this too to include it as a whole formula. Because if I'm going to build an equation, if I find the area of the entire deck, so I'm going to say area of the deck is equal to the
40.
Yeah, you're right.
Yeah,
5 times 8 will be
times
40. Yeah, exactly. This here is 40 meters squared because that's our 5 times our 8. But let's think about this. The area of a deck will be our length times our width. And our new formula, our width is this value, and our length is this value. So our new area has to actually include everything. It has to be all, that entire shape there. So not only is the inside 40, but the outside is 68. We need to put the two of them together. Okay, so I need to take this area, the area of the deck. I'm going to say, sorry, total area instead of just area of the deck. I'll call this area total. And the area of the deck plus the area of the pool is equal to the area total. So to find our total area of the deck is 68. Area of the pool is 40. Our total area is 108. And we'll say it's in meters. Okay, is our total area.
Yeah.
So let's build an equation now. So remember, like we said, total area is equal to length times width, and we're going to highlight them. Our new length is this, so replace it, and our new width is this, and our actual area itself is 108. So we have 108 is equal to length, which is 8 plus 2x, width, which is 5 plus 2x. Okay, so I've built a formula here. So let's FOIL. This will still be 108 on this side.
Yeah.
So we FOIL here. 8 times 5 is our 40. 8 times 2 is our 16x. 2 times is our 10x. And 2 times 2 is our 4x squared. I'm going to rearrange this.
Yeah.
Just because. Did you see how I FOILed that? Was
Yeah.
that too fast?
No,
yeah.
no,
I
saw
did
it.
these
Yeah.
two, then those, then those, and then those. I'm going to rearrange it the way polynomials is usually written, where the x squared is the first term. I'll combine my like terms in the middle.
Yeah.
26x and plus 40. Well, it's equal to 108, which can be really hard to solve for in a quadratic. It's actually really easy, though, we know to solve for when something is set equal to 0.
Yeah.
So in order to set this equal to 0, what do I do with that 108?
Bring it to the other side.
Exactly.
Minus 108.
Minus 108. So now we get 0 is equal to 4x squared plus 26x. And that's going to be minus 68.
Yeah.
Minus 68. Good. Okay. Now, x, if you recall, is our width. So we have to find our x. So this is where I'm going to use my quadratic formula again to solve. Because I might be able to factor it, but it might be relatively difficult.
Yeah.
So x is equal to negative b. So I'm just, do you need me to write the formula out again?
No.
No? So negative b would be what? Negative?
Negative 26.
Yeah. You know what? I'll write it on top just to confirm everything. Okay, plus or minus the root of b squared minus 4ac, just in case you forget if you go watch this again. Oh, those are funny colors. 2a. Okay, so our b term, which is our 26, so it becomes negative 26 plus or minus the square root of 26 squared minus 4 times our a value,
4
which is 4.
times negative 68.
Yeah, and our c value, which is negative 68. And all of that will be divided by
2 times 4.
That's right. 2 times our a value, which was 4 again. So we go about equating this. Negative 26 plus or minus the root of 26 squared (676). Negative 4 times 4 is negative 16,
Yeah.
and negative 16 times negative 68.
1088.
Yeah, positive 1088. All divided by 8. Well, we got to find our root. Negative 26 plus or minus the root of, I think that's going to be 1,000.
17,064.
Beautiful. Divided by 8. Again, this is where you can split an equation, or you can actually find the root first. Let's do that. Is it on the dot?
Yeah.
Oh, wow. That was nice. Plus or minus.
42.
Oh, sorry. No longer a square root. 42. Over 8. Great. Now, this is where I would usually split the equations. Okay. I would go x is equal to negative 26 plus 42 over 8. And x is equal to negative 26 minus 42 over 8. Now, just before we even solve, because we're finding 2, I want you to quickly look at this. This will be a negative, subtract another value. It's going to be a large negative divided by 8. What kind of answer are we going to get?
A negative.
A negative. Can you have a negative width of a deck?
Nope.
So this will be kind of our illogical answer. That one won't make sense. So this is probably the one we want to focus on. 26 minus 42.
16.
Okay. That works out beautifully. 16 over 8 is a width of 2. So 2 meters is probably our answer. Let's see what our illogical answer was. What is that? 68? Negative 68 divided by 8, which gives us 8.5?
Yep.
Negative 8.5 meters. Well, negative 8.5 meters is definitely not an option for the width of this stack.
Yeah.
Right? But 2 meters is an option for the width of this stack. So if we go back up, we recall that x was equal to 2. So that means the width of this deck all the way around was 2 meters.